Hi folks, I just got home a few hours ago from imaging Comet 209P linear, and I hopped on YouTube, and lo and behold, there's a new video about this comet. And I swear, I didn't know about it. I know it was published the day before, but I didn't know about it till I got home and saw that it was there. So by a complete coincidence, I just happened to have taken a new picture of this comet. And so here's this video about it, claiming that it's huge, and that it's the closest comet on record to come by Earth. So let's watch it and see what it says.
This is a Thor News presentation. Thor News presents Comets.
All right, ladies and gentlemen, I am Thor, and I'm back and better than ever. And hey, guess what? I'm talking about comets. And you may be saying to yourself, and I'm going to confess ahead of time, the comet icing experience left me sad, jaded, and cynical. So it was with great hesitation I'm stepping back in with periodic Comet 209 linear. But I will say, I try not to sensationalize too much. I just try and stick to the facts and make it funny and interesting. But I will give you this. Comet 209P linear looks huge, giant, massive, giant. All right, you might be new to this whole game, and you're asking yourself, what is a comet? And since I have super hearing, I can hear you ask that question, so I can tell you,
Okay, so he claims it's huge and that it's the closest comet coming by Earth on record. And let's tackle that last claim first here real quick. If you go onto the Minor Planet website, you can see the list of the closest comets to have come by Earth. And it's not the closest comet on record. And in fact, there was one that was even closer in our lifetimes in 1983, Comet IRAS-Arecibo-Alcock. It was co-discovered by the IRAS telescope and by a couple of amateur astronomers as well. And that one came almost twice as close as 209P will get to Earth. It's true, 209P will get quite close. But it is very dim, very faint, so much so that even though it will be one of the top closest comets to come by Earth, it will make this list you see here, it will not be naked eye magnitude at close approach. That is how dim this comet is. You will need a telescope to see it. So prepare for a lot of disappointment. I'm seeing a lot of hype about this comet on YouTube, and most people are never going to see this comet unless it's on a computer screen. Even at close approach, binoculars won't cut it. It will be around magnitude 10 currently projected. So unless it experiences a significant outburst, you're not going to see this comet unless it's in a telescope. I took a picture this morning of the comet, and it's in this picture. What? Where? Well, let's see. I overlaid the Palomar Sky Survey, a plate from the Palomar Sky Survey on top of my image. And you can see all the stars match up, but what's this here? See that blinking there? There's something in my image that's not in the Palomar Sky Survey plates. And what that actually is Comet linear. Now, he shows this comet on stereo Ahead HI2. I've taken the raw data from February 26th and cropped it and processed it myself, and you can see there is a comet there. That's true. But it's not the comet he says it is. He says he likes to stick to the facts and not sensationalize, but this isn't even the right comet. 209P linear is a very faint, very small comet. Just how small? Well, in this image, I've astrometrically solved the same image you just saw, and I've turned it to color intensity mode. So the colors correspond to the intensity of the pixels. I can change that back to grayscale here real quick so you can see. This is the same image. And when I go to color intensity mode, you can see more contrast. You can see the comet better. If you look up here in the top right window right here, it'll show a magnified view of whatever I'm pointing at. So you can see right there, 209P linear. There it is in all of its glory. That's all there is to it. Now, in terms of how big that is, the radius of the circle that you see right there is 7.3 arc seconds. And you can see that completely encircles the comet. That's it. So it's got a total diameter of about 14 arc seconds. And at the distance of the comet at the time this was imaged, that corresponds to a diameter of ballparking it somewhere in the order of about 6,000 kilometers or so. As comets go, that's tiny, and it's important to note That's the diameter of the entire thing that we can see, the coma, not the nucleus. The actual coma surrounding the nucleus, all the gas and dust that comet's emitting. And that's much larger than the actual physical nucleus. It doesn't take a very large nucleus to produce a huge coma. And the same principle applies to rockets, in fact. When a rocket launches, after it's done launching, they dump all the fuel that's left over. And that forms a cloud in space. And sometimes people see these clouds and mistake them for UFOs or mysterious things because they can form very interesting shapes that span multiple degrees of the sky, even though the rocket itself, the rocket stage, whatever's left over in space, is so tiny that if you see it at all, it just looks like a moving star. You can't resolve it by eye. It's only a couple arc seconds across. But the cloud it creates, with even just the leftover fuel, can span multiple degrees of the sky, orders of magnitude larger than the originating body. It's the same principle with comets. And it's the same principle here. So the actual physical nucleus is quite small, but the total size of the coma is only about 6,000 kilometers. That might sound like a lot, but as comets go, that is tiny. Even Ison, which you heard Thor mention, that comet disappointed everybody, but that one was many times larger than this. Now the comet he's showing, let's go back to that for a second. So he's showing this comet here. Now I've processed the raw data to preserve the stars in the image and astrometrically solve it, and you can see it moving there. You can see the tail and everything. I mean, that's way more significant than what my image shows, right? So why is that? Well, let's look at the astrometry. So in this image, I've cropped down on the comet, and the comet's right in the center of the image, and the center of the image corresponds to these coordinates here. Now, if you look at where that is in the sky from the perspective of Stereohead, the stereo spacecraft that took this picture, what you see is its Comet Lovejoy, C2013 R1. It's a completely different comet. Completely different. In fact, it's this comet right here. I took a picture of Comet Lovejoy as well on a previous date, and I took this with my wide field telescope. Now, the image you saw before from my scope, the image of Comet Linear, again, right there, 209p linear, that's with the 8-inch LX200 Schmidt-Cassegrain. This is a much smaller field of view than this image here. And as you can see, this comet spans a huge portion of space. That's why it looks as significant as it does in those stereo images, and that's pretty typical for a comet. This is a pretty run-of-the-mill comet that did reach about naked eye magnitude, I believe, but didn't really put on a huge show, nothing like Hale-Bopp or anything. But it puts on a nice display if you've got a telescope and a camera. And that is the comet he's showing. He's not showing 209p linear. Now, I think it's interesting. Some people sometimes accuse me of parroting NASA. I'm not parroting anyone. I'm taking my own images. I'm doing my own measurements. I'm doing my own calculations. I'm not parroting anyone. It's interesting to me that he actually is parroting someone. It's not NASA, but he is parroting someone who made the exact same mistake just a few days ago, using the exact same images, the same images from the stereo spacecraft. We have here BP Earthwatch, and on February 28th, he makes the exact same misidentification.
Here's linear coming in. It's still about to do its...
Nope, that's not linear. There it is again, Lovejoy. This over here, Arcturus. We can go back to our view here. There's Arcturus. There's Lovejoy. If I zoom out a little bit, you'll see, okay, here's Venus and Mars, and you can see those in the stereo image as well. There's Mars and Venus. So, yeah, he's showing here Lovejoy, and he's calling it 209p linear. And I strongly suspect that's where Thor got his information, because just a day later? Yeah, March 1st. Now he's claiming the exact same thing, that this is 209p linear. It's not. So it's funny. The people accuse me of parroting NASA, but I'm not. Like I said, I'm taking my own images. You can see them here. There it is. That's all there is to it. That's all there is to this comet. It's not a NASA image. It's me. I took this picture, and I measured it myself. And it's small. It's dim. It's small. It's faint. You need a very powerful telescope to see it. But some of the people claiming that it's huge are actually parroting each other. I think that's kind of ironic. So, with that, I hope you have a nice day.